So now we will see the numerical based on differentiation under integral sign and having the two parameters. So here in this question we have two parameters a and b, and we have to evaluate the value of this integral, and then we have to deduce that the value of this integration is equal to pi by a upon a square minus b square whole raised to 3 by 2. Now guys, here to get this value or to evaluate this first integral, we can solve it by the DUIS method, or we may apply the method which we have learned in 12th standard. So here to evaluate this first integral, I will use the method of 12th standard, and then to deduce this result we will apply the rule of DUIS. So let's start. Now if you will see the question, so I is equal to integration 0 to pi dx upon a plus b cos x. And guys, we have seen this type of numericals in 12th standard, and to get the value of this type of integration is very easy, hence we will follow that method only. So when such type of integration comes where the denominator is a plus b cos x, or a plus b sin x, or a sin x plus b cos x plus c, that time what do we do? So we all know that we put t equals to tan x by 2. So here we get dt as the derivative of this part, that is sec square x by 2 into 1 by 2 into dx. Now by solving this, here we can take this 2 on the left hand side, so 2 dt is equal to sec square x by 2 into dx. Now I'll rewrite this sec square x by 2 in terms of tan. So we know that 1 plus tan square theta is sec square theta, so this will be 1 plus tan square x by 2 into dx, and I have already shifted 2 on the left hand side. Now this tan x by 2 is t, so this will become 1 plus t square, and we can take this 1 plus t square in the denominator. So guys, therefore we get dx as 2 dt upon 1 plus t square. So here we got the substitution for dx as 2 dt upon 1 plus t square, and for that we'll put t as tan x by 2. Now what about the cos x? So cos x can be represented as 1 minus t square upon 1 plus t square, because t is tan x by 2, so this will be 1 minus tan square x by 2 upon 1 plus tan square x by 2, which is the formula of cos x. So here we got all the substitution. Now we just have to check the limits. So limit is from 0 to pi. So for x it is 0 to pi. Let's check it out for t. Now when x is 0, the lower limit is 0, this will become tan 0 upon 2, that is tan 0, and tan 0 is 0, so t will be 0. Next x is pi, so this will become tan pi by 2, which is infinity, so t will be infinity. So it means limits are changing from 0 to infinity for t. So I'll write down all these terms in this integral I. So here we will get, therefore I equals to integration 0 to infinity. Next we have 1 upon a plus b cos x. Cos x is this value, so here I'll say it is 1 upon a plus b into 1 minus t square upon 1 plus t square, and the value of dx is 2 dt upon 1 plus t square, so into 2 dt upon 1 plus t square. Now let's solve this. So here I can take 2 outside, integration 0 to infinity, will get dt in the numerator. Here 1 plus t square will multiply with this a, will get a into 1 plus t square plus b into 1 minus t square upon 1 plus t square, and that will be cancelled with this 1 plus t square. Now let's solve this. So I'll take t square terms together. So 0 to infinity dt upon, so a into t square minus b into t square. So here I'll say a minus b into t square plus, this is a into 1 is a, b into 1 is b, and a plus b in the second bracket. Now guys, here this a plus b is a constant, as well as the a minus b is also constant. Now to get the value by integration, I'll divide this denominator and then multiply the denominator with a minus b. So here we will get integration 0 to infinity dt upon, so first of all we'll divide with a minus b. So here we will get t square plus a plus b by a minus b, and here by dividing with a minus b or by multiplying to denominator with a minus b, here we will get 2 upon a minus b. Now if we'll write down this term as root and then square of this, here we can apply the formula of integration, that is the formula of tan inverse. So this will become is equal to 2 upon a minus b is as it is, then 1 upon square root of a plus b upon a minus b into tan inverse of t upon square root of a plus b upon a minus b from 0 to infinity. Now here we can rewrite this a minus b as root of a minus b into root of a minus b, and one root will be cancelled with this root, and here we will get 2 upon 1 root, that is a minus b remaining, and from here root of a plus b. Here we will put infinity here, so we'll get tan inverse infinity as pi by 2, and when we'll put 0, then tan inverse 0 is 0, so no need to write. Then we can cancel this 2 and 2. So here only pi remains, and root of a minus b into a plus b is square root of a square minus b square. This will remain. So it means we got the value of integration is this. Now we'll rewrite the integration. So this was the value of I. So here I'll say therefore integration 0 to pi dx upon a plus b cos x is equal to pi by a square plus b in the square root a square minus b square. Now guys, let's move to the deduction. So we have to deduce this result, and now to deduce this result we will apply the rule of DUIS. So for that I'll call this result as equation number 1, and we will apply the DUIS on this equation number 1. So by DUIS, what do we do? So we find out the partial differentiation with respect to the parameters. So here there are two parameters, a and b. So if you'll observe carefully, then we want answer as dx upon a plus b cos x the whole square in the integral. Now to get this value, we have to differentiate this either with respect to a or with respect to b. Now if I differentiate with respect to b partially, then here we will get cos x as an extra term in the numerator after doing the differentiation. But if we differentiate partially with respect to a, then we will get square in the denominator, and in the numerator we will get 1. So we can match with this value. So therefore we will apply the DUIs with respect to a. So here I say the rule of DUIs is like this. it is di by dA equals to integration, let's say here it is from 0 to pi, dou by dou A of function of, this is function of x and a, and also the parameter is b, into dx. So this is the rule of DUIS, by which we will differentiate the function which is in the integral partially with respect to a, and will differentiate this value with respect to a, but it should be a complete differentiation. So let's start. So here, by partially differentiating with respect to a, we will get integration 0 to infinity minus 1 upon a plus b cos x the whole square into 1 dx equals to, and here we will differentiate this function with respect to a, so pi is outside, and differentiation of this will be a square minus b square, this is raised to minus half. So first of all I write down the function and then we'll differentiate. So here I've just differentiated on the left hand side, and here I've taken the denominator in the numerator. So by differentiation this will give us pi as it is, and this will become minus 1 by 2 a square minus b square raised to minus 3 by 2 into 2a. Now guys, here we can cancel this 2, and here we have negative sign on both sides, so we will cancel the negative sign from the both sides. So here we'll get integration 0 to infinity dx upon a plus b cos x the whole square, and here pi a, and we'll send this value in the denominator, so the power will become positive and we'll get a square minus b square raised to 3 by 2. And guys, if you'll see the result, then it is exactly matching with our question. So we had to prove this, and we have proved this result over here. So here we have seen the numerical which we have solved it by using DUIS, and if you want to see such more videos on engineering mathematics, then do not forget to log into ekeeda.com and search engineering mathematics, and you can enjoy the magic of mathematics. Thank you very much.